Hello and welcome back to the MoDyPy Basics tutorial series. My name is Ralf, and in this tutorial I will show you how to sample the thrust from our DC engine at regular time intervals. If you are the kind of person who rather reads tutorials instead of watching them, hop over to docs.modypy.org, where you will find this tutorial series in text form. In this tutorial, we will introduce discrete time elements. We will do so to sample the thrust provided by our engine block at regular time intervals. And for that, we will create a zero order halt block, and we will add a clock to it that will trigger it at regular time intervals. And in the end, we will plot both the actual thrust and the sampled thrust. Here we have the code from the last tutorial with our engine block and our simple system setup with a constant voltage and a constant density, sampling or plotting the resulting thrust. We want to extend this model by a zero order halt element. And for that, we need a state to hold the sampled value, and we need a clock to provide the clock signal at which to sample. So in addition to our engine, we now create our sample state. And the sample state is a simple state, but it does not have a derivative function. It is constant except when we change its value explicitly. So we don't specify a derivative function. That is also important so that the simulator knows that it is a discrete time state. If you have a system that only consists of discrete time states, then a different simulation system is used than the one that is used for systems including continuous time states. We also need a clock. And we set the time period of that clock to 0.01 seconds. So the clock will expire every 0.01 seconds, and it will start doing so at time 0. We can specify differently, and we can also specify whether the clock shall be running before the start time already or only start at the start time. The difference between the two is if we say it starts at the start time, well then the start time is obviously the time at which the clock starts. But if we say it starts even before, then the start time is only a phase shift of an otherwise infinitely running clock. And now we need an event handler, so something that will update the value of the sample state to the value of our thrust when the clock expires. We call that update sample, and as most of the functions in MoDyPy, it accepts a system state object. And we simply set the value of the sample state to the value of the thrust of our engine. Now we need to connect that event handler to our clock. And to do so, we simply call the register listener method on the clock and pass it the update sample function. This is just the same method that we used when we registered listeners for zero crossing events. Actually, both clocks and zero crossing events are event sources, and both are handled in a similar way regarding their interface. So that's actually all for the definition of our sampling. Now we want to plot the results. We want to plot our continuous time thrust in red, and we will plot the steps of our sample state in green. And here we need to make sure that we do the step at the right point, and that is the point where the sampling happens. Otherwise, Matplotlib will plot the stairs the wrong way around. So let's run the simulation. And we can see that the thrust has been sampled. We can now reduce the simulation time a little bit to see a little bit better. So here we see our steps, and we see that it has been sampled at the correct time, at the correct level. Now, because we will be using these kind of zero order hold elements many times in discrete time control systems, there is a predefined block for it. For that, we will simply import from the discrete block library. For that, we will simply import from the discrete block library the zero order hold element. And now we can simply say sample state equals zero order hold. We specify the system. We specify the event port, which is the clock. And we specify the input port, which is our engine thrust. And we need to declare the clock before the sample state here. And we can remove all of that. So because the zero order hold takes care of all of this. And if we run this again, we see the same result. So that is the simple introduction into discrete time systems in MoDyPy. Note that you can define as many clocks as you want. So you can have different time systems for different parts of the system, or you can have clocks shifted against each other to model response times from software. And there's a lot that you can do with the discrete time system in MoDyPy. So that's it for this tutorial. There's still a lot to come. However, now we stop working with the simulator. The next tutorials will be about systems analysis. We will be doing steady state analysis and linearization of systems to assist in designing control systems. So stay tuned. I hope to see you back soon.